Homework 7 is due now. Homework 8 is due a week from today. You can pick up, if you don't already have a copy of that, you can pick it up after class, and it's posted as a PDF online. We are continuing with rate of return analysis, which is basically all about decision making and trying to identify projects that are worth doing or not worth doing. And we're going to be using the computers a lot over the coming weeks. And it's important that you know how to do these techniques because it's going to be included on the next test that we have. The next exam is going to have one of the questions you'll solve with the computer. And so it's really important. If you didn't bring a computer today, that's fine. But be sure to use the recorded lecture and go through the techniques so that you know how to do the internal rate of return and the other things that we're going to be doing through the rest of the week. So any questions related to the announcements? Yeah. Mm-hmm. Yeah.
When there is a final salvage value posted, that doesn't matter, does it?
Right, yeah. If there's equipment you're holding on to forever, then you wouldn't get a salvage value. But if you're comparing two things and one of them does have a salvage value, then you need to take that into account. Did you see the sign on the door? Okay. Yeah, so if you're comparing two things, then one of them is going to be converted into an annual basis. If it's infinite, then it's easy to convert it to an annual basis because you're just multiplying the interest rate by the initial purchase price. But for the other one, where there's a purchase price, annual operating expenses, and a salvage value, then you do account for the other alternative.
Because I think one of them had the infinite had a salvage value, but that's what we use. I just like this.
Yeah, you don't. All right. All right, let's take a look at why interest rates matter. This is a truck that's for sale here in Huntington. I took this screenshot off of the internet today. It's a very expensive truck. I don't know who would pay $54,000 for a truck, but I think there are plenty of people who do that because everywhere you look, there's really expensive trucks on the road. So let's say, for instance, that you have a truck that you're going to pay $54,000 for, and you think that if you make that purchase, you can earn an additional $900 per month in revenue. And that's after the operating costs. That's after you've already covered the fuel and insurance. And so you're trying to figure out if you should do it. I looked at a couple of different bank websites this morning and found interest rates. And so Huntington Bank, for instance, for a 66-month loan is offering an APR of 4.72%. And that's the annual percentage rate. Although you're paying your loan monthly, if you annualize the interest rate, then it's 4.72%. In comparison, there's a much smaller organization in town, Star USA Federal Credit Union. I don't even know where their branches are, but their interest rates are as low as 2.75%. So let's do a comparison of that. I put together a spreadsheet that shows the effective interest rate. All right. So here we have the truck. It is $54,105, and so that's what I've put as the initial cost of the equipment. And we have two interest rates we're going to be comparing, 2.75% and 4.72%. Make that a little bit bigger so you can see. All right. So these are both annual interest rates, and so if I put in, for instance, 0.0275, then on a monthly basis, here's the interest rate per month. We simply divide the annual interest rate by 12, and here's the initial purchase price and the monthly revenue. And so I've set up the standard cash flow diagram where we've got the initial purchase price as an outflow. All those monthly inflows you can see are the same amount, but what's not the same is the present value of those amounts, because the money in the future, 66 months from now, The $900 that you earn 66 months from now has a present value of only $774. And so we can add up all of the present values. And do you remember what's the criteria for a yes or a no on a project when it comes to present worth analysis? No. It's a good guess, but that's not the criteria. How do we say yes or no to a project? Right. So if you're using the MAR for the interest rate and you discount all of the future amounts to the present and combine it with the initial purchase price, then if it's above 0, then that means yes, do the project. And if it's below 0, that means no, don't do the project. So here, when we have the interest rate of 2.75%, then that says, yes, we should do the project, because that means we're going to have a positive present worth at this interest rate. So 2.75%, it seems like this is a good decision to buy the truck. But if we're using a different interest rate, if we're using the higher one, 0.0472, then now the present worth is negative. And the reason why is that those future values, the revenue we get in the future, is worth less if we're discounting it at a higher interest rate. And so that turns a good investment decision into a bad investment decision. And it seems like a relatively small difference in interest rates, 2.75% versus 4.72%. But that small difference in interest rates has a huge effect on the bottom line. It turns it into a project where essentially you'd be doing all this extra work and losing money in the process. And so the whole point of the illustration is just to show that interest rates matter. And what we're going to be looking at today is how you can evaluate projects by not just finding the present worth, the future worth, or annual worth, but how you can evaluate projects on the basis of what interest rate they return. All right, so here's an illustration of the internal rate of return, abbreviated IRR, and how we use it for decision making. The scale is showing a balance in the cash inflows and the cash outflows. When you operate a business, what do you want to have heavier, the inflows or the outflows? What do you want more of? You want more inflows than outflows, right? And so internal rate of return is if we were to solve for an interest rate that makes it so the inflows and the outflows are in balance, then that's what we call the internal rate of return. So going back to this illustration, right now the inflows and the outflows are not in balance because there's more outflow than inflow when we have 4.72%. When we have 2.75%, they're also not in balance yet, because right now we've got more revenue than costs. But we could play around with this interest rate a bunch of times and find out what is the interest rate that makes it so that the total present worth is 0, meaning that the outflows are in equilibrium with the inflows. And so if we said 3%, it's getting closer. 3.5%, we've gone too far. So we're getting awfully close at 3.4%. And of course, the easy way to do this is with the what-if analysis, because then you can use goal-seek to automatically, we want this total to be equal to 0 by changing the interest rate. And we tell it to optimize, and it finds exactly it's 3.401%. And so this would be the internal rate of return. The internal rate of return is some unknown interest rate that makes it so that the inflows and the outflows are in balance. So sort of conceptually, you can think of it as a scale where the inflows and the outflows are the same. So in words, it's the interest rate that equates the two. You can only calculate the internal rate of return when you have revenues and when the revenues are bigger than the costs. You know, there are some alternatives, like when a city is making a park or when you are dredging a shipping channel. There are a lot of examples where you're simply not going to make enough revenue to justify a project, and you're doing it for other reasons besides profit. Internal rate of return can't be calculated if you have more costs than revenues. The function simply won't work in Excel. The easiest way for us to solve for the internal rate of return because of the iterative nature of it is to use Excel, or there are some ways to do it graphically. So here's the analysis criteria. This is what you have to know on whether a project is thumbs up or thumbs down. I star is the variable that we use to internal rate of return. So if you can earn more on a project than your minimum acceptable rate of return, in other words, if the interest rate that you're returning that's coming to you is bigger than the minimum, then you accept the project. And oftentimes your minimum acceptable is tied to borrowing costs. But if your rate of return for a certain project is less than the minimum, then you should reject the project. All right, so the rate of return, the full name of it is internal rate of return. I star is what we're using for the variable. Now, it can be thought of two ways depending on where your money came from. If you're borrowing for a project, then it's the rate that you're paying on the yet unpaid balance of borrowed money. Or if it's your money that you're investing, then it's the rate that you're earning on the unrecovered balance. And last time in class, we did a spreadsheet where you were calculating unrecovered balance over time, and so you know what that phrase means. When the two are in equilibrium, when there is a balance in inflow and outflow, then this is the internal rate of return. So here's a cash flow diagram that's showing some investment in year 0, a little bit of revenue in year 1, and so on. What we could do is we could translate this picture into a table that has in one column the year, another column the amount, and then the third column would be the present worth of the amount, and we would want to find out what is the interest rate that makes it so all of the inflows and outflows are equal. Revenues equals expenses. And so here's the formula that's shown in your book. And this is maybe at first glance a little more complicated than it actually is. But let's talk through what this equation means. It means, first of all, you're going to be finding the present worth and you're discounting the amounts or compounding them at the interest rate that you don't yet know. I prime means an unknown interest rate. So you have to iterate, means you're starting with some guess value and then you play around with the guess interest rate value until all of the revenues and all of the expenses, when combined, equal to 0. And then that's how you know you have the correct interest rate, is when the revenues and expenses equal 0. So graphically, here is a curve that shows when you're trying to guess what is the correct internal rate of return. If you're guessing the interest rate is small, then the present worth will be large, because what that means is that the money in the future is artificially appearing to be more valuable than it actually is. And so going back to the Excel example that I showed you, look at the present worth when we use a small interest rate. So here the x-axis is I and the y-axis is present worth of the cash flow diagram. All right, so when we used a small interest rate of, let's say, 2%, then we have a big present worth, so it's positive. So here on this curve, when you have a small interest rate, the present worths are positive because what it does is it's not discounting these future amounts by very much. They're retaining more of their value over time. But when you use a larger interest rate, then it becomes negative. And so back to the figure here, when you have a big interest rate, the present worths are negative. And so what we could do is we could substitute in a lot of different interest rates and then find an amount, do a graphical interpolation of that curve and solve for what is the interest rate that causes the present worths to be 0. In other words, looking for the intercept with this axis. And in fact, that's one of the steps I'll ask you to do during the in-class exercise today, is solve for the intercept of that axis. Now, there are a couple of things we have to be careful with when it comes to internal rate of return. It's okay to compare your project to the MAR. In fact, that's what you're supposed to do. That's how you're supposed to make your decisions. But there's a really dangerous thing to do, and what you can't do is compare internal rates of return between two projects and then choose which project is best based on that. I'll illustrate why that doesn't work, why the highest IRR isn't necessarily the best project. But what you need to know for now is that the IRR alone, this factor, the internal rate of return, can't help you to identify the best project among alternatives. It's just sort of an initial screening tool. It's a yes or a no for each of the alternatives. The other big assumption behind the internal rate of return is what you can do with the revenue that you're getting. Because internal rate of return assumes that all of the revenue you're receiving for a project is being reinvested in that project and is earning compound interest at the original interest rate. So a savings account is an example where that is true. All of the money that you earn in a savings account, you can leave in the account and it can continue to compound additional interest inside of the savings account. But let's say if we go back to the example of the truck. If you're purchasing a truck and you're spending $54,000 to do it, all of the revenue that you're getting over those months, it's not like you're reinvesting that back into buying another part of a truck. The revenue that you get has to be put in some sort of other investment, whether it's a savings account or trying to build up other aspects of your business. And so sometimes it's not the case that you can reinvest your money back into the original project that you purchased. Sometimes it's possible, sometimes it's not. But you need to know these conditions for the exam. You know, in the exam we have some short answer and conceptual questions, and oftentimes one of the questions I'll ask about is the assumptions behind the internal rate of return. And what's here in bold is important to learn and understand. All right, any questions about internal rate of return as a concept before we get into today's specific in-class exercise? All right, so here's what we're going to do. It looks like most people have computers today. That's great. If you don't have a computer, then you can still work on this by scoot next to somebody. The first one is an Excel problem. The second one, you're doing like some hand calculations and interpolation to solve for the internal rate of return. We have a cash flow diagram that you're going to have to find the present worth of the cash flow diagram using some different interest rates. Once you've found the present worth at those different interest rates, you have to start either iterating or interpolating in order to find what value will give you a present worth equal to 0. The IRR function is beautiful. It doesn't need very much to work. All you have to do is say equals IRR and then highlight all of the numbers, including what's in year 0. Remember when you were using NPV, you had to avoid what was already in year 0? This time for the IRR, you don't do that. You just highlight the entire cash flow diagram, the amounts, not the converted present worth amounts, just the original amounts. So equals IRR, you select a range, and then it will tell you the IRR in percentage. You may need to change the number of decimals that are shown in order to see anything other than the standard 8%. But if you increase the number of digits, then you should get it to match what you had found through the optimization you did yourself when you were doing the what-if analysis goal seek.